Hello, my name is James Hermes. I'm a graduate student in mechanical engineering at MIT. Today I'll be presenting our work titled Exploiting Redundancy to Facilitate Physical Interaction. The control of kinematically redundant robots is often approached using null space projection, which requires precise models and can be computationally challenging. In robotics, examples of redundant robots range from 7 to 26 degrees of freedom. In contrast, biology frequently presents a daunting amount of kinematic complexity on the order of 100 or more degrees of freedom. If this complexity is a limitation to control, why is it so prevalent in biology? It seems unlikely that biology relies on precise mathematical models and complex computation. In this work, our experiments revealed that when the dimensionality of the null space is increased, the impedance superposition was comparable to null space projection. Given an n-link system, one can add end effector impedance through control. This makes the first system functionally look like the second. However, with a redundant system, this leaves additional joint degrees of freedom unregulated. For example, during a cyclical task, the robot can drift into joint limits or singularities. Fortunately, there's a well-known solution to this problem. A constant rotational stiffness can be added at each joint, which we will denote mechanical impedance superposition. In this case, the combined system will no longer have the desired end effector properties. The conflict between joint space and end effector space causes a steady state error. This error is frequently referred to as a task conflict. To deal with this conflict, a null space projector can be added. This matrix multiplication eliminates the torques which conflict with the end effector task. Now the robot will move in the desired way. However, the projection comes at a cost, loss of passivity and challenges its singularities. In theory, superimposing impedances will always result in a task conflict, while null space projection eliminates the task conflict completely. Interestingly, we found that in practice, null space projections do result in small errors. And when the null space dimension is large enough, superposition was comparable to null space projection. In this experiment, the KUKA LBR EWA and InMotion robots were connected by a U-joint and bearing system, which decoupled the rotation of the two robots. In the unconstrained condition, the InMotion served to measure the LBR behavior, while in the constrained condition, it also enforced the dynamics of a circular constraint. The LBR was programmed to investigate two main conditions, the 1D null space and 4D null space. In the 1D null space condition, the end effector task included 3 translational and 3 rotational degrees of freedom. The 4D null space condition was created by eliminating the 3 rotational degrees of freedom. In this experiment, the goal was to regulate the translational behavior in the plane of the InMotion robot. Thus, the RMS error in the unconstrained case was the normal distance from the circle to the actual position. As expected, in the 1D null space condition, superposition resulted in a large task conflict, while the null space projection almost eliminated the task conflict completely. Interestingly, in the 4D null space condition, the task conflict observed from superposition and null space projection were comparable. This was quantified by the RMS error and was observed across a variety of conditions, including different speeds, different stiffnesses, and constraints. In conclusion, when the null space dimension was increased, superposition was comparable to null space projection. This made us wonder, is dimensionality actually a blessing, not a curse? In addition, I want to clarify that we're not saying null space projectors are bad. In fact, we quantified cases where null space projectors were particularly useful. Instead, we're saying impedance superposition may be better for biological type cases. In these cases, where only small joint space stiffnesses are required, or large null space dimensions are possible. I'd like to acknowledge our collaborators and funding sources. Thank you.